Good morning. How are you all doing? She didn't mention huge nerd, Van Halen fan, dog lover. Anyway, it's true. I'm Sam Ramji. I'm a product manager for Google Cloud Platform. Now, I focus on DevOps, which is what we do when we engineer the systems for Google's developers to work at high velocity and with high reliability. And we're bringing that to users around the world. I've been in enterprise software for about 2 decades, working in middleware, open source, APIs, and cloud computing. So you can see why I'm so happy to be here at Interop, a show fundamentally about interoperability and networking, right? To strengthen businesses, to be able to spread technology around the world, to reach many, many more people worldwide through a key set of promises. Now, before I get seriously started, my team and I did a little research. And ahead of today's talk, we realized that this is the 30th anniversary of Interop. So originally it was called Network and Interop back in 1988. So reflecting a little bit on that, here's the map of ARPANET back then. What an amazing journey we've all been on, right? So this bet of Interop, that TCP/IP technology, designed so all kinds of computers could connect, would be a big thing. You think they were right? So there were 60,000 hosts connected to the internet at that point. Now, we've got over 1 billion hosts and over 4 billion people connecting to the internet every single day. So say it kind of worked out. One interesting thing is that this explosion of connectivity has also led to a golden age of software development. Right? So this connectivity bonanza, right, has helped us leverage APIs and microservices, right? More applications, more utility, going more places. It's pretty spectacular. You can see some of this at Interop itself, in fact. On the show floor, as far as we can tell, the first 50 exhibitors who funded the first Interop were mostly selling boxes. Whereas today, on the show floor, in the conferences, the conversation's really about software. Right? So these kinds of trends are what led us to cloud computing, arguably the greatest current expression of connection and software utility. But I want to focus on the magic. So the magic wasn't in the wires. We actually had hardline connections across the country far before 1988. The magic was actually in the protocol and the principles. The protocol, TCP/IP, published in the early 70s by Vint Cerf and Bob Kahn, was built in layers. And the principles were that we would work very hard. We would all commit to interoperability. That's a big deal. Now, Vint Cerf, working at Google these days, says that permissionless innovation is actually the greatest gift of the internet. It has enabled businesses that were unimagined in 1988. In fact, we benefited greatly from that. We have developed 7 different products that have over 1 billion users each. There is no way this could happen without interoperability at massive scale that each and every one of us in this room have invested in, day out for decades. Right? Permissionless innovation has enabled all sorts of connectivity and new business models. It's also created new challenges. Here's a map of Google's network today. So it includes undersea fiber optic cables, points of presence, edge nodes, and as we grew our business, the demands grew very fast, in some cases exponentially. Now you have to remember this is back in the early 2000s, so we actually had to invent a number of the technologies that are now considered fundamental to cloud computing, because we had the same problems that any IT shop had. Right? We had to be able to support many different business units internally, search, ads, YouTube, doing permissionless innovation at scale on a bigger stack, including but going beyond TCP/IP to include compute, storage, other types of networking, and many new services. So the cloud's foundational technologies, particularly containers, are really why it's possible to put computation anywhere that you want it. Edge devices, your data center, big public clouds. And they're increasingly the nexus for building, storing, shipping, analyzing, coordinating. Right? This same thing that we do with shipping containers, we can now do with units of compute. So as we keep those lessons from TCP/IP very close, we know that we need to focus on building in layers, and we need to all commit to interoperate. So with that scale that I talked about, it can seem like Google is from another planet. But in fact, we're not aliens, we're fellow travelers. Every company's DNA is the same DNA. It's human DNA. Managers can feel overwhelmed by the pace of change. Often it's because they don't have a good model for management. They are stuck in the illusion of permanence. They want to be able to restrain things, contain them to the way that they have been in the past, right? when our ideals are hampered by older styles of computing, of systems management, of organization, right, then we end up suffering. So we've been through the exact same struggles because humans are humans everywhere. But we're an industry company. We're in the advertising industry. So we've adapted these lessons and learned how to build software, change our models to be effective. And there's room for companies in all industries to apply lessons from the journey, right? Whether it's in healthcare, energy, agriculture, right? No matter what industry or industries you're in, this is a common set of lessons because it works for humans, it's written by humans. You know your business best, you know your digital future best. So you've been on an amazing journey. What lessons can we learn from the history of TCP/IP? What lessons can we learn from what Google has practiced? I'd like to share with you today a few things, 3 lessons that we've learned over the last 19 years, a cognitive frame that has helped us be successful, and then 3 guiding principles or questions that you can ask to orient yourself, things that we ask ourselves pretty much every day and every week. First, what have we learned? When in doubt, connect. What does this mean? It means if you build a system that can't easily connect, you'll probably regret it in the future. Now, this doesn't mean that every single system we build has to be open and accessible by default from the start, but you have to build with that capability in mind. Why? Because by the time there's a demand for your system to be open, it's almost certain that that demand was driven by competition from the market. Somebody else built a more open system, they have first mover advantage, and they probably beat you. So by the time you add that openness, it's too late, right? The market's moved on. We've learned this lesson the hard way. Software economics win. Now, a really important principle we found is that problems that can be reduced to software will be reduced to software, right? Few things stay special forever. So if you expect it to be so, plan for it to be so, and believe in automation. So as Quentin Hardy, who's the former deputy technology editor for the New York Times, says, we tend towards software. It's almost like a economic gravity well. Everything kind of falls into that, and we tend to seek software-oriented solutions. Third, embrace the ecosystem. Now, today's most valuable businesses are valuable due to the strength of the ecosystem that depends on it and that drives it forward, right? So our best businesses are the ones that we built with the fundamental expectations that we're going to benefit from the ecosystem, that the economic value is going to be built hand in hand together. The ones where we haven't done that, well, you probably have already forgotten those products. This leads us to a cognitive frame around openness, abundance, and empowerment. We really think that these are the new rules for leadership in the digital age, right? We think that today's most impactful technology strategies actually are built on these 3 rules. So for openness, we mean things like open source, right? Open sharing of ideas embedded in technology, right? Your ability to freely come and go. If you're managing internally on the free flow of talent, if you're able to share ideas internally, whether or not you share them with the entire world, then you'll end up in a much, much better state. At Google, we're actually able to see all of the source code, 9 million source files. From day one as an engineer, you can change search. A brand new Google engineer can break search. But that's really useful because what an extraordinary teaching tool that is to bring everybody up to speed quickly. Abundance. Abundance and scarcity are tricky things for human beings. So abundance now exists in the form of APIs in the API economy. It exists in the form of freely available, nearly freely available compute, storage, and networking. It's available in the tools that we use. And then finally, empowerment kind of builds on this whole system. We want to be able to lower the cost of risk and increase the rewards for experimentation. Somehow we want our people to feel like that they can try new things, take risks while keeping the lights on. All of that has to do with self-service. Arguably the most important thing about cloud computing is the empowerment that it gives your people when they don't have to file a ticket to get a new server, but where they can just have a low-cost experiment that might scale up. So these 3 things are absolutely crucial. I want to talk about this a little bit more because the truth about technology is easy. Change is hard. And that's for very good reasons about how people think. So a quick story. A few economists in England did some research on the cost of light over time. So it turns out the dark ages were really dark. Light was expensive. From the era 1300 to the year 1800, the cost of light only improved by a factor of 3. So these economists measured lumens per pound sterling. Simple, right? Now, from 1800 to 2000, how much did the cost of light improve? A factor of 3,300. Now, that's not 3,300%, that's 3,300x. We changed the world, and you can see our cities from space because light is cheap and super abundant. But we were able to see that change almost evolutionary, right? Over generations of time, every single person was able to see an improvement in light in their lifetime, but it wasn't 3,300x in one shot. Now think about us, right? So what did we think when we grew up? I know that programming on a Commodore PET with 8K of memory in 1980, right? Memory is really scarce. Compute cycles are really scarce. But maybe not. So from 1992 to 2012, the cost of compute cycles improved by a factor of 3,700. It's a lot. So it lets us start to shift and say, well, maybe compute's not scarce. What are we protecting anyway? Hold on to your hats if you think that's a lot. The performance of storage improved by a factor of 18,900 in that same time. So in one human generation, such flabbergasting change that you've never seen in centuries before. So no wonder we struggle a bit with these systems of control where we're trying to restrict access to what's now really an abundant resource. What we want to do is recognize the abundance, empower employees to use it, and then recognize the new scarcity, which is really human ingenuity. So taking that frame, the three most powerful questions that we've found to ask consistently and recurrently are simple but profound. So first, are we managing for change? We know the rate of change is increasing. Is the model that we had in place a couple years ago that we were really happy about still fast enough? Second, do we have an effective model? What are we using our human time and attention for? What are we doing with the machines? And then third, are we open? So I'll get a little bit more into each of these. So people talk about corporate transformations with technology, and high-paid gurus make fortunes selling top-down transformation strategies. But I think those of us in this room all know that real change starts with people doing work, changing the tools they use. The optimal tool for the right problem, right? How do you grow those over time? So these tools, in the spirit of TCP/IP, in the spirit of Interop, are all about optimizing data flows, making sure that humans and data can interop easily. How do you have a shared view across the organization? So when we think about continuous improvement, things that we've learned from the Toyota production system, right? Mechanisms like the management principle from Edwards Deming, blame the process, not the people. These are all about being able to get into a process where we can build constantly, we can release constantly, we can continually operate and monitor, and we can continuously improve. Now this really calls on managers to act very differently, right? Beginning with new ways of measuring. One interesting thing at Google is that we have something called an error budget. So we have a service level objective that says, we want to see 5 nines of availability. And if you drop to 4 nines, and if that performance continues to not meet expectations, you eat into your error budget. You consume enough error budget, the development team can no longer add new features. So this is a technique of being able to bring together developers and operators in a new way. Typically, developers want to build at high velocity. Operators want to have high reliability. So developers say, well, give me a system that lets me push to production whenever I want. The operators say, forget it. You're going to break it all the time. My pager's going to go off, and I'm going to have a terrible life. So step one, give pagers to the developers. Trust me, developers who carry pagers write better software. Step two, make sure that everybody's on the same page so they have the same rewards. You'll get better teamwork and better behavior. If the developers are just as responsible for reliability as the operators, and the operators are just as responsible for velocity as the developers, you now get rid of the silos, you get rid of the ghettoization that we're so used to in technology, and you create happy human beings. It's really one of the most important principles, right? One thing that we found is that the farther the distance is between two organizations, the more likely they are not just to point the finger at each other, but to assert that those people are fools. Now, all you have to do is put them on a different team, and the other team becomes the fool. So this is just one of those human structures that you have. If everybody has the same incentives, same measurement, same rewards, you will build better software and be happier with the result. So while ship and keep shipping constantly embeds the principle of things never being perfect, that can also be a challenge to thinking. We need to be able to be willing to live there constantly while constantly improving. Don't seek finite states faster. Seek a continuously improving state as quickly as possible and be comfortable that nothing's ever going to be up to your satisfaction. So when we think about waterfall, those old days believed that you had a highly predictable target, that you could say 18 months from now, the market will want this, and we're going to spend 18 months building the software. But now, of course, that's broken. So with the speed that the world's moving at, that's really the change we have to manage against. How are we satisfying them with our internal systems? Second, do we have an effective model, right? Your humans are absolutely precious. I want to talk a little bit about abundance and scarcity. So we believe that there is a shortfall, a demand that is so much higher than supply for developers worldwide that we can only measure it in millions. There's currently about a 5 million person shortfall between how many developers are needed, how many jobs are open, and how many are available. Now, no matter how many how many babies we make and how fast we put people through school, that is not a gap that we're going to close quickly. So we have to start thinking about that as scarce. Zulfi just gave a brilliant talk talking about security. Now, security professionals are in a similar supply gap. The demand for security professionals is about 2 million people higher today than the supply. Again, not a skills gap we're going to close really soon. So we have to figure out, what are we doing in our model to make sure that our humans are doing the best possible work? So the 3 things that we've observed. First, moving to digital platforms, right? As your enterprises become entirely platform-centric, as you move beyond lots of siloization, heterogeneous systems, respecting the legacy but starting to build a common way of looking at all, observability across your infrastructure becomes absolutely critical. What we found at Google is that observability at scale becomes a data science problem. So think about this. Some of your people who know the context of IT the best, might be time to cross-train them in data science so they can start to get these bigger aggregate pictures of how you're actually performing. That data is going to be incredibly valuable to every line of business, to every departmental IT org that you possess. Second, auto update. Now, automation is as old as technology itself, right? But we should be automating vulnerability patches, application upgrades, work streams. Anything that a person could do that could be automated, they should be paid to automate. Now, that might mean that their skills change. That might mean you need to take them from being systems administrators to site reliability engineers. They know network operations really well. They know the operating system level really well. But getting them out of command line activity and up into programming repeatability, working alongside with their development partners, so that when you have a production down incident, you can go back and say, well, let's change the software, let's put in new tests, and let's make sure not only does that one problem never recur, but let's make sure that that class of problem never happens again, right? So there's a job transformation that becomes possible once you embrace this kind of automation, auto-update thinking. And then finally, like everyone, we seek economies of scale. So drive down costs by concentrating energies, respond quickly to positive signals, shut off negative ones. Interesting things that we and others have started to share with the Open Compute project. If you're interested in data center infrastructure designs, we published many of what makes Google special, including things like using 48-volt power in our racks. So there's a lot of innovation available that's freely understandable, and those economies of scale are obviously available in the cloud. We don't believe that the cloud is the only way to run software. We actually think that the durable state of software it's going to be everywhere, a lot like electricity. It's not only offered by large utilities, but there's generators all throughout this building that we depend on constantly, and probably in the buildings that you're in as well. So this durable state is sort of striped computation everywhere. So when you have a strong foundation like this, observability, auto-update, economies of scale, you have a powerful new tool, and of course that will lead us to need to manage in new ways, like any new tool. Brings me to the third question. Are we open? Do we have a transparent organization, or are we still living in the old way of management by hoarding information? We know that information wants to be free, but corporate politics can mean that information is valuable, and if I have it, then you don't have it, and now we've got a new scarcity cycle. But if we can encourage transparency, if we can create a blameless culture, particularly with something that we call blameless postmortems, rewarding people for raising the flag and saying, I think this is a problem, this broke, how do we fix it? Let's all get together and discuss the entire process. Then we start to again channel what Toyota Production Systems learned by saying any single employee can pull the red cord, stop the entire line, everyone will cluster around, say, oh my gosh, what's the problem? What can we learn? And how do we make sure that that problem never recurs? So there's a set of rewards and transparency that have to go back hand in hand. If somebody feels like they're going to be rewarded for being transparent, you're going to be in good shape. But that's a really difficult part of what you all have to do as you move your organizations forward into these kinds of systems. Now, we think that this is the best possible way to create a high-velocity environment that attracts talented people and grows institutional knowledge. So for us, this is simple economics today. It also reads on how we share technology. So if we think about open source, we think about open culture, we think about the open cloud, people are going to want to share. So we think open source is a better standards body than traditional methods, right? Instead of having a small cabal that meets every couple of years to define a new version of the specification, we have practitioners working constantly. Kubernetes is an example of that. It's not just a cloud technology, but it's something that you can use anywhere you have containers, anywhere that you could care to orchestrate a cluster. Should work the same anywhere that you want. And it's constantly updated. It's in the top 0.01% of open source projects today, freely available, and the community is participating at a scale and a velocity that it boggles my mind personally. I've never seen an open source project grow as fast as this. Another one that's really important is Istio. So this is a service mesh, a way that regardless of how your applications have been built, you can expose a service that you can see, track, manage, or anywhere in your global infrastructure. This is really important for being able to access it, for being able to govern it, to be able to audit it. So again, the idea that you're creating new abundance means that you've got new scarcity. As you have all these new services, the scarcity becomes service management. So it's important to be able to have an open, easy to access, ideally free way to be able to implement that for the entire system. Now, I'm very proud to announce today that we are open sourcing a project called Asilo. So Asilo is about being able to have provable security. It's confidential computing. One of the great things about the abundance of containers is that you can take them and run them anywhere. But do you trust their execution environment? You may have incredibly high-value intellectual property embedded in the code running in one of those containers. Maybe it's your hedge fund trading algorithm, literally the crown jewels of the company. How can you trust that that can run anywhere in the cloud? There are a range of very highly functioning but very proprietary chip technologies, like Intel's Secure Enclave or SGX, AMD's SEV, that require different programming techniques and recompilation of all of your applications in order to use them. What those do guarantee, though, is that the code can't be seen by the cloud provider when it's executing. What Asilo does is simplifies your approach so that you can point at any container and say, I want this entire container to run in secure mode. Not only should it have data encrypted in transit, data encrypted at rest, but the actual running code that I have in the cloud, I want that to be able to be completely opaque to the provider. I want it encrypted at runtime. So this is a pretty new field, but it's exciting to be able to build on the security practices that we've used inside Google to make sure that we have security at scale across our entire global infrastructure, much as we do with container management and service management, and take these and make of them gifts to the world, right? Taking open source Borg and providing open source Kubernetes, taking things like Nubi and our service management system and offering that as Istio, and now much of our security technology we're offering as Asilo. So we're excited to see where this goes. So in closing, we'll think about how are we managing, how effective are, how open are we? Is there a model that companies are using that's working, right? Do traditional companies make the transition? We've actually seen our customers migrate to the cloud to change how they approach IT, right? How they build software, how they operate their businesses, how they differentiate. Motivated by these inspirational examples, we've teamed up with a landmark research team called DORA, or DevOps Research and Assessment. This is a company founded by leading practitioners of DevOps who started the movement over a decade ago, looking for a scientific assessment and a process for guiding hundreds of companies to be able to adopt these new, more formal models that move at speed and produce happier humans. So you'll see ongoing research from DORA, sponsored by Google and many other companies. I strongly encourage you to take a look at this. It's a practice of being able to learn from each other, and I think that's my most important closing thought. Whether you're a digital native, born on the cloud company, whether you're a traditional enterprise, maybe as old as 100, 150 years, we all have things to learn from each other. We have to embrace the legacy, because without the legacy, many great businesses simply wouldn't exist, and embrace what's new, right? How do we pattern these things together? I love to spend time in the wilderness, and one thing that I've found is that no matter what group you're in, it's the diversity that makes us incredibly strong. Everybody's got a different point of view, a different strength, and that's how we get from point A to B to C to parts completely unknown. So I hope that we'll all practice sharing knowledge. I hope we'll all take the lessons of TCP and Interop formally to our hearts, right? Let's make sure that we practice the protocol and the principles. Let's build together in layers, and let's commit to work together on interoperability. So with that, I thank you very much for your time. Hope this has been a good use of your heartbeats.